have a test for tomorrow.
Okay.
So I will send you a picture of it.
Okay. Let me know when it says file sent. What kind of stuff are we looking at tonight?
It's like subtracting and adding
Polynomials or imaginary numbers?
I think it said file sent, but yeah.
Let me have a look. Because it definitely will not get to me. No, it did. Okay. Let's see if I can blow this up a little bit. Good. So which ones are equivalent? Okay, here, let me turn my writing pen on. Let's look at this one right here. What's the first step in that problem? Solving it.
What is the first step?
What's the first thing you want to do?
Do you wanna do the parentheses first, right?
Yes. So what is u to the minus fourth to the fourth power?
Is that just u?
No, you multiply exponents.
You multiply?
When you are doing what I call double exponentiation, which is what's going on here, in other words, u is being taken to the minus 4, and then the whole thing is being taken to the fourth. So when you have double exponentiation, that's when you multiply the exponents.
Okay.
Okay, so now we have this. 2u squared. What can we do with these two v's?
You can add the...
Okay, so that becomes v to the 6th. And the bottom is what?
U to the negative 16th.
Okay. And now what can we do with that? We are dividing. So what are we going to do with the exponents?
You subtract them.
Okay, so what does that give you?
It gives you u to the negative 14th.
No. What is 2 minus a minus 16? That's what you do when you subtract them.
Oh, it's 14.
It's 18.
Oh, okay.
2 plus 16, which is 18. And that all goes in the numerator. So that's what that thing simplifies to. And that happens to be what they've written.
Yeah.
Okay, let's have a look at the next one. What's the first thing? Can you read that okay? Or at least you're looking at the paper also, huh?
Yeah.
So, let me just have a gander at it. How are you going to tell if these are the same things or not?
Would you just multiply out the x minus 9 squared in the parentheses?
Perfect. What does that give you? Let's do it one step at a time. So all
Well,
we're
it
doing
would
is
give you
squaring the x minus 9. So when you square that, what do you get?
x squared and then minus 81.
Nope. It's the biggest mistake made in algebra. When you square x minus 9, you are multiplying x minus 9 times itself. Foil that.
Oh, would it be a positive?
No, foil it.
Foil it.
Don't try to answer it in one. It looks like it would be x squared minus 81 or plus 81, but it isn't. If you FOIL it, you get x squared minus 9x minus another 9x plus 81. So this in the parentheses becomes that after you square it.
Oh, okay.
Okay, so let me write that in there. Here, it's x squared minus 18x plus 81. Now distribute. Oh, plus 11. I don't want to forget that plus 11. Should be easy enough after the next step to tell whether these two things are identical or not. What do you get when you distribute?
Well, 1/3 x squared. And then I don't really know what 1/3 times 18 is.
You don't? You don't know what 18 divided by 3 is?
Oh.
6.
Yeah. And then
So it's minus 6x. Now notice I don't have to go any further. If
yeah,
I look at what they're comparing it to, they got minus 1/3 x.
Yeah.
Okay. If I were to finish the problem, I'd have 1/3 of 81, which is 27. And then I got to add 11 to that, which makes it 38. So that's what I get when I expand that left side. And that is nowhere near what they are saying it's maybe equal to.
Yeah.
All right, let's go number 2. What kind of problem is number 2?
A division?
It's a factoring problem. Whenever you see stuff like that, it is a division problem, but these are almost never division problems.
Mm-hmm.
You factor everything that you can factor, and then you cancel stuff.
Okay.
So, starting in the top left, what can I do to that 4x minus 20?
You can take out a 2.
You can take out more than a 2.
Yeah, you take out a 4.
Okay, so that becomes 4 times x minus 5. And then how about the next term in the numerator? X squared plus 2x minus 15. That actually factors rather nicely also. How does that factor? Sounds like you need to review your factoring.
Yeah.
There is probably nothing more important in Algebra 2 than being able to factor.
Okay.
If you can't factor, you're going to be lost instantly. Every problem we're looking at on this page is a factoring problem.
Mm-hmm.
Okay? So let's look at this and talk about how we're going to factor it.
Oh, wouldn't it be one of them would be
What method have they taught you to do this? Because there are a bunch of them out there.
the X one, like where you put it in like a little diamond thing.
Okay, can you do that?
Yeah.
Because that's not the method I teach. I don't really like that method. I find it confusing. I find all students don't remember it. Most students don't remember it. And it's not necessary on easy factoring problems like this. It's not at all necessary. This is a very easy factoring problem using very easy method. I'll go over my method. First thing is you break up the x squareds. Well, you can't produce x squared unless you have an x there and an x there. Second thing is you determine both signs. You don't try to solve this thing in one step in your head, and that's what most students do. You're sitting there trying desperately to find two things that will multiply together. That's not the way to do it. You do it, you eat an elephant one bite at a time.
Yeah.
Okay? So the second step is to figure out both signs. Well, they have to be plus minus, because you cannot produce a negative 15 unless they are opposite signs. If those signs were the same, that would be a positive number, not a negative number. And now the third step, pretty easy. I'm looking for factors of 15 that subtract, because of that negative sign, to the number 2. What are factors of 15 that subtract to 2?
5 and 3.
Perfect. Now, which one goes with the plus sign? That's the third step. You figured that's the first 3 steps. And there's only a fourth step. I'm going to put the bigger factor that I found with the sign of the middle term. So the 5's got to go there, and the 3's got to go there. Okay? So that's what that quadratic factors into. Now, we got to deal with the bottom. Because what's going to happen is I'm going to factor the whole bottom, and then I'm going to cancel like crazy. All these problems are of that nature. Okay? So this term right over here, x squared minus 25, how does that factor? That's difference of perfect squares.
So what does that mean?
Whenever what it means is this. That is a perfect square, x squared, and 25 is a perfect square. If that was 26, it wouldn't be a perfect square. 25 is a perfect square number. It's 5 squared.
Yeah.
Okay? And it's the difference of perfect squares because they're being subtracted. So it's pretty easy to recognize difference of perfect squares. You're looking at 2 perfect squares and they're being subtracted. That's why it's called the difference of perfect squares. And how does it factor? It factors like this. Whenever you have the difference of perfect squares, factors into a minus b times a plus b. So we have the difference of perfect squares there. How does that factor? Instead of saying a squared minus b squared, this says x squared minus 25. So the a must be the x, and the b squared must be 25, so b would be 5. So it factors into x minus 5 times x plus 5. Okay. Now the only thing left is that one. What can I do with that?
Well, you can factor out the 2.
Let's do it. You'll see that that's very helpful.
Mm.
What's left over?
Just x at -3.
Okay, now watch what happens. I'm going to cancel that with that. I'm going to cancel that with that. Cancel that with that. What have I got left over? 4/2. Here's your answer.
Okay.
Like I said, all of these problems we're looking at are going to be of this nature, where you have to factor each the numerator as good as you can and the denominator as good as you can.
Yeah.
And then you'll find that a lot of stuff starts canceling out. Okay?
Okay.
Now, B is harder because it's much harder to factor. And given the difficulties that you had in factoring that, which is a simple quadratic fraction, I think we should go to problem 3A, and if we have time, we'll come back and we'll do that one.
Okay.
But there's no point in having you practice problems that you can't do when you can't do an easy one.
Okay.
So if we're going to work on factoring, we need to work on easy.
Yeah.
I don't mind, and I think we should work on factor. And like I said, there is nothing more important to be able to do in algebra than factor. You are going to be lost if you cannot factor. Now, 3A is also a factoring problem. It just looks a little different. What is divide by a fraction? What am I going to do? Am I really going to divide?
No, you're going to copy dot flop or whatever that thing is.
All right, so I've got this. So what I'm looking at is p minus 9 over p plus 9. And instead of dividing, I'm going to multiply it by what?
You're going to multiply it by 2 p9 or p plus 9 over 10.
And now what can I cancel? That's what you're always looking for, is where can you cancel stuff?
Can't you cancel the 2p plus 9s?
Uh-huh.
And then can you cancel the 10s?
Uh-huh. Hold on. Excuse me. I think I'm done sneezing. Yeah, we have all multiplication going on, so I can definitely cancel those 10s. And now the only thing left over. Excuse me, I'm sorry. When you live with 2 dogs, you're always sneezing. So the only thing I have left over is 2 times p minus 9, because I didn't get rid of the 2, and there's p minus 9. And that's your answer. And if you want to multiply those together, that's fine. It's 2p minus 18.
Mm-hmm.
Either one of them probably will suffice.
Yeah.
Whenever you see this divide sign there, you're never dividing. You're always multiplying.
Mm-hmm.
Always. I haven't seen a division sign that, well, that's not totally true. When you get into actually dividing polynomials by linear factors, you might see a divide sign where you'd have to actually do long division.
Yeah.
Let's go down and do B, because B is a lot more like the problems you're going to be seeing. Okay. Mm-hmm. Now, in order to do B, you got to be able to factor all 4. You got to be able to factor both numerators and both denominators. So let's start on the numerator on the left. In fact, here's how I'm going to do this problem. I'm just going to have you factor everything, and then we'll put it all back together.
Okay.
All right. So let's use the same pattern or method that we did before.
Mm-hmm.
What's the first step?
So split the two ends in between those two.
Second step.
Put the signs down.
What are they?
A minus first, and then a plus.
No. If they were opposite like that, you would not be looking at a plus 24. Remember what factoring is, Matt. What you're doing is the opposite of FOILing. Okay? In other words, if you have two linear terms that you are multiplying together, you're going to FOIL them, right?
Uh-huh.
So when you're factoring, you're doing the opposite of FOILing. Well,
Okay.
when you FOIL, and the last step of FOILing is multiplying that number by that number to produce this number, always.
Uh-huh.
Always. Okay? So when I am factoring and I see a plus 24, that tells me something about my two signs. They have to be the same. They either have to be minus minus or plus plus.
Mm-hmm.
The most important thing to look for when you are factoring, when you look at this whole thing, that right there is the most important thing to see.
Okay.
Because that will tell you what both signs are. Now, in this case, are they both negative or are they both positive?
Both positive.
No. This, the second thing to look for. There's no way that middle term could be negative if they were both positive. Everything would be positive. We would not have any negative terms at all. So once you determine that both signs have to be the same, look to the middle term to determine what those signs have to be. That tells you they both have to be negative.
Okay.
Okay? Now, what's the third step in factoring?
Figuring out what multiplies to 24 and adds to 11.
Perfect. Let's go over here and figure out all the factors of 24. Give me another factor of 24. Factors.
12 and 2.
Keep going.
6 and 4.
Keep going.
8 and 3.
Aha, we just found our answer.
Yeah.
We wanted factors of 24 that add to the number 11. Now you'll notice in this case there's no necessary fourth step. I can put the 3 on the left and the 8 on the right, or vice versa. So it really doesn't matter because both signs are the same.
Yeah.
So a lot of factoring problems are simple 3-step problems. You just got to memorize the 3 steps.
Mm-hmm.
Okay? And then occasionally they're 4-step problems. If that sign on the constant is a negative, then there's always a 4th step.
Yeah.
Then you have to figure out which number goes with which sign. Okay, so we factored that one. Let's go to the next one. How about 10n minus 20? Factor that.
So you'd want to take out 10, and then you're left with n minus 10.
Okay. The way I want you to do these is when you write a number down here, I want you to immediately check it and see if it's right. Does that multiply together to give you that?
Oh, no.
So what do I need to do? This number's got to be wrong. What does this number have to be?
It has to be 2.
Okay. That's the way you should do all math. Is every time you do a calculation, if there's an easy way to check it, you should.
Okay.
Because that's when to do it. You don't want to wait until you're finished with the problem, because we got a lot more steps on this problem. I got to factor the denominator on the left and the right. So I got a whole bunch of stuff to do. but I don't want to get done, come up with the wrong answer, and then have to go back to step one to figure out where I made my mistake.
Yeah.
Always be checking.
Okay.
ABC, always be checking.
Okay.
Okay? So now let's look at what's on the lower left. Let's factor that as well as we can.
So would you add the two exponents first?
No. First of all, you only do that when you're multiplying the variables. We're not multiplying the variables here. We're subtracting.
Yeah.
So you can't operate. N cubed minus n squared is n cubed minus n squared. It does not simplify. However, I can factor. What's the greatest common factor in those two terms?
10.
That's the greatest number, but there's also a variable that can come out of there.
Oh, 10n.
10n squared. Remember, you're looking for the greatest common factor.
Oh, okay.
You're not just looking for a factor. You're looking for the largest one. Now, what's left?
An n minus 3.
Perfect. Okay, now the last thing is that quadratic down there. Let's factor that. That's a normal looking quadratic, meaning, in fact, this is by normal looking, I mean it's got a 1 as the coefficient in front of the squared term.
Yeah.
Those are the easy ones. You've got to be able to do those. And you can do all of those using my very simple method, not that complicated, confusing method they teach you called the California method.
Mm-hmm.
When you get to harder quadratics like these, they're going to be harder to do, granted. But 90% of the ones you're going to have to do on your test are going to be the easy ones.
Yeah.
So if you can do the easy ones, you're going to be doing just fine. Okay? I'll show you how to attempt to do the harder ones if we have time, but let's do this one the normal way that we just did a couple of them.
Okay, so
yeah.
take the two ends and split them. And then it would be both signs as a negative. And it would be 8 and 2.
Okay. See how easy it is? Just 3 straight steps there.
Yeah.
Okay, now let's see. I've written this a little peculiar. This is my top left numerator. This is my top, I don't need the word top. That's what numerator means. So this is my right numerator. This is my left denominator, and this is my right denominator. So first of all, let's look at, and they're all being multiplied. Okay? So is there anything from this line that I can cancel with one of these denominators? And it doesn't matter which one.
The n minus 8.
That n minus 8 goes with that n minus 8. What else?
And then the n minus 3.
Goes with that n minus 3. Okay? So now here's what we're left with. We don't have anything left on the left side. And when I say nothing, there's actually a 1 there. When I'm canceling these things, I'm replacing it with the number 1.
Okay.
Okay? So what's left on the top is 10 times n minus 2. What's left on the bottom is 10n squared times n minus 2. This n minus 2 over here. In other words, we could have canceled those two out also.
Yeah.
Okay. And I can cancel the 10s out. So what am I left with? 1 over n squared. In other words, all that complicated thing usually boils down to something pretty simple. In other words, they set up all these problems so that these will all cancel one another.
Yeah.
Or most of them will. Okay? Now, do you have another page, or is this it on this page?
This is all I really needed help with on this page.
Let's work on that one right there then, the one I skipped over. So, these are a little bit harder, but same principle. The first step, instead of splitting up the r squared, you're splitting up the 3r squared.
Okay.
So how would you split up 3r squared? Only really one way to do it.
Well, I mean, would you just put 3r on both sides?
Well, now immediately check. Is that right? Remember, this term comes totally from this term multiplied by that term.
Oh, okay. So it'd be
100%, not partially, but 100% of the time. It comes from the f of FOIL. So it's not 3r, because those two multiply back together to give you 9r squared.
Yeah.
So what's it got to be?
1/2.
No, just r.
Oh, okay.
3r times r is 3r squared.
Yeah.
Okay, now what are my signs? Step 2 is actually the same.
Well, they're both negatives.
No. Remember what I said. Your very next thing you're looking at after splitting up those r squareds is you staring at that thing right there. That gives you a lot of information about this problem. What does it tell you both signs have to be?
Doesn't one have to be positive, one has to be negative?
Yeah, they have to be opposite.
Mm-hmm.
Okay, so now the difference on problems like this is that plus minus is not the same as minus plus, because this first term is a 3r, this first term is an r. So these numbers that I still have to fill in aren't going to both be multiplying r. One of them is going to multiply 3r, the other is going to multiply r.
Yeah.
So when these are different coefficients in front of the r, which they are here, I have to allow for both scenarios. It might be plus minus, but it might be minus plus, and that would be a different answer. Okay? Now, we know we're going to be looking for factors of 70, because the one thing we know for sure is that you got to produce this minus 70 with that L of FOIL.
Yeah.
So let's go through all the factors of 70. You can cut this first number in half, always do so, and double the next.
Okay, so 35 and 2.
Okay. Now I cannot cut 35 and a half anymore. I can't cut it in a third, but I can cut it in a fifth. So what is a fifth of 35?
A fifth of 35?
35 divided by 5.
Oh, 7.
Since I took a fifth of 35, I got to multiply the 2 by 5, making it 10. Okay. Now, I'm going to look at the right side. Can I do anything with that last set of factors? Can I cut 10 in half? I can.
Yeah.
And double that. Now, if I go back to the left side, I can cut 14 in half again, but I just get back to the 2 previous factors, so it doesn't do me any good to do it anymore. I believe that is the only 4 possible answers. Okay? Now, we can pretty much throw that one out. The reason is if I put 70 on one side of this, there's no way I'm ever going to get to 11 in the middle.
Yeah.
Because this middle term is made up of two terms. It's made up of the O and the I of FOIL. In other words, this term is just the F of FOIL. This term is just the L of FOIL. But that middle term is the O and the I. So we're going to have to experiment a little bit here. In other words, at this point, it becomes a total trial and error process.
Yeah.
And it's a trial and error process, whether you're doing it by your California method or you're doing it by my method. It doesn't matter. And what I tell everybody to start with is always try the two closest factors. Well, 7 is close to 10, right?
Yeah.
Closer than 14 is to 5 or 35 is to 2. So I'm going to start with 7 and 10. And I can see right away that if I put a 10 there, that ain't going to work.
Yeah.
And the reason being is that 10 has to multiply 3r. So if I try this combination, I get plus 7r from the inside. I get minus 30r from the outside. Combine those two, I get minus 23r. Okay?
Yeah.
So that tells me I don't have the right number. So this is not the right answer.
Yeah.
Now, once you do these a while, you realize that if I move the 7 down to here and the 10 down to there, which is another option, is all that I do is change the sign of that 23. I make it a plus.
Yeah.
So that can't be the right answer either. We got to get to 11 and minus 11. Okay? So I know the 7 can't go on the left and the 10 on the right. So let's reverse it. In other words, this is a different answer. Okay?
Yeah.
Now, what do you produce as a middle term in your final quadratic with this answer? What's the inside multiply to?
10r.
And the outside?
21r.
Negative
21r.
21r. In other words, you're multiplying it by that.
Yeah.
Okay? Combine both of those, you get minus 11r. Bingo, we found our answer.
Yeah.
Now, had my third choice, or my second choice, had I accidentally put a 10 there and a 7 here, I would have discovered I got plus 11r. Well, now I know what my answer is. I just got to move the 10 to the positive sign and the 7 up to the negative sign, and I have my complete answer.
Yeah.
Okay? So that's how you do those. Okay? Now let's work with the denominator. So, well, first of all, here, our answer here was the top one. So let me erase some of this other stuff here. That should be minus 7. And if you were to if your life depended on it, you would multiply these back together again to make sure you got that, right?
Yeah.
Well, usually your life doesn't depend on it, so we don't need to do that. But we know we got the right answer because we split our 3r squareds up properly. We split the 70 up properly. And we just checked the two inside terms, and we got 11r. So I don't need to check it. I'm real confident that I got it. Okay. Now, let's do the other one. Here, let me do it separately down here. 2r squared minus 4r minus 70. Notice there is one thing I can do first that turns this into a simple quadratic, not a hard quadratic. What is
No,
it?
you can take 2 out of everything.
And that makes a big difference, because
Yeah.
what it leaves is r squared minus 2r minus 35. And that is a first level quadratic, meaning I can solve it in 4 steps.
Yeah.
Always with the same pattern. It's no longer a trial and error quadratic. So let's factor that. What is that?
So it'd be R and R, and then plus and minus, and then
Vocalize the last step for me.
vocalize the last step, like
Factors of 35 that do what?
that add to 2.
Not add. That's a negative sign.
Oh, subtract to 2.
And it's always that sign. In other words, if that was a positive sign, they would need to add to 2. If it's a negative sign, they got to subtract to 2. Well, what factors of 35 subtract to 2? Think of the close ones. There's only one, actually. There's 35 and 1, and then there's, what else? What 2 numbers multiply to 35?
7 and 7 and 5.
Okay, and those subtract to 2. So those are our 2 numbers, but we got to decide where the 7 goes and where the 5 goes. Now you look to the middle term. The sign on the middle term is negative.
Yeah.
A bigger factor goes with that sign. So the 7 goes there, 5 goes there. Okay, so now let's erase the quadratic, which is replaced by this. And now we've got this numerator, this denominator. Is there anything we can cancel?
R minus 7.
Now here, what we're left with, what's left on the numerator?
3R plus 10.
What's left in the denominator?
R plus 5.
And don't forget that too.
Oh, yeah, 2R plus 5.
Okay, and I'm going to go ahead and multiply that out. You don't necessarily have to. That is our final answer, and it cannot be simplified. Not cancel those 10s with one another because they're both being added. This is not multiplication that's happening. Okay?
Yeah.
So that's how you do that one. In other words, there was really only one hard quadratic to do, and that was that one. Once you factored out the 2 from this one, it became a level 1 quadratic, which is really easy.
Yeah.
Okay. So that is that. Have any other problems you want to go over? We'll practice some factoring.
Actually, I just have this one. It says rewrite the following expression in exponential form, and it's m and then 7 divided by 3 as like an exponent.
Like that?
Yeah.
Rewrite it how?
As an exponential form.
Okay. What a fractional exponent means is the denominator of the exponent is the root. The numerator is, in other words, that becomes the cube root of m to the 7th. Now, that's not quite right. Well, that's a true statement. In other words, if I have m to the 1/2, that's the square root of m.
Yeah.
In other words, these fractional exponents mean exactly what I said they mean. The thing is that I can simplify this answer a little bit. And the best way to explain to you how to simplify that is, I don't know. I'm going to explain it two different ways. It's m to the 6/3 times m to the 1/3. Is it not?
It is.
In other words, if I add those two exponents together, I get 7/3. So I can separate it into this. Well, that is m squared times m to the 1/3, right?
Yeah.
And that is m squared times the cube root of m. So that is technically the correct answer. In other words, you always want to pull out as many whole m's as you can.
Yeah.
That's why this first answer wasn't really correct, because I can still pull out an m squared from inside here. When you take the cube root of m to the 7th, you get m squared times the cube root of m. Okay? But in terms of just terminology, if I have, what's this mean?
What does that mean?
Yeah, if I want to write that in radical form, how would I write it? Using radicals.
Would it be just the square root of x to the 3rd?
It's not the square root. Remember, the denominator number is the root, so it's the cube root.
Cube root, yeah.
And then the numerator goes there. And that, if they were to give you that problem, that's what they're looking for as an answer.
Yeah.
Now, if they give you this problem, it's a little different, because that is the square root of x cubed, but that is the square root of x squared times the square root of x, and that becomes an x. So this one over here becomes just x times square root of x. That's what that would mean.
Yeah.
So the rules, you have to bring out whatever you can bring out from under the radical sign. But a lot of times you can't bring out any. I can't bring out anything on the radical sign when I'm taking the cube root of x squared.
Yeah.
How about anything else, Matt? You got any other questions?
Let me look.
These exponents are a pretty big deal. Let me just give you a couple exponent problems. Tell me what that's equal to.
X to the 7th.
Okay. Tell me what this is equal to.
X to the 18th.
Okay. You know how to handle your exponents. One last thing. Tell me what that's equal to.
X minus 2? Wait.
No.
Wait, it's okay.
X to the minus 2 exponent. That minus 2 is an exponent.
Okay.
So what does a negative exponent mean? Means the reciprocal.
Oh, so it would just be a positive?
Well, it's just on the other side of the fraction bar. In other words, what I really had was x to the minus 2 over 1.
Yeah.
So I just moved the x to the minus 2 to the other side of the fraction bar and changed it to x to the plus 2.
Okay.
And you can always do that with a negative exponent. In other words, if I have this, I can take this part of it and just move it to the other side of the fraction bar so that it becomes 2x to the positive 3.
Yeah.
It doesn't matter whether it starts in the numerator or the denominator. If you have a negative exponent, just move it on the other side of the fraction bar. That should cover all your exponents, the rules for exponents, which are very critical also. Rules
Yeah.
for exponents and factoring, if you can master those two subjects, you're going to do good on any algebra test.
Yeah.
Because it usually comes down to those two topics. I mean, there's a lot of other stuff also, but obviously, but there's not much more important than factoring and exponents, how you handle exponents and how you factor.
Yeah.
Anything else?
I don't think so.
Okay. Well, I will let you go then.
All right. Thank you.
Enjoy the rest of your evening. I'll talk to you next time.
All right. See you.